provide heat. So I will explain you today the structure and working of Hope's apparatus. So before explaining, just see here, this is a formula of density equals to mass upon volume. That means volume is inversely proportional to the density. Volume is inversely proportional to density. If we provide heat to any liquid or water, then that expand. And because of expand of this water or any liquid, the volume will increase. Because volume will increase, then density will decrease. But if we cool that water, if we contract, if we remove the heat from the water, then the water will contract and this volume will decrease. And volume will decrease, then the density will increase. Clear this concept? So, just see here, this is a cylindrical container. This is a cylindrical container, and here in between the fixed bowl is attached, and this flat bowl contains the freezing mixture of salt and ice. Freezing mixture of salt and ice. Water contained in these cylinders and also in this flat bowl. This is a simple beaker. Then here two thermometers T1 and T2. First, just assume that initially the temperature of water is 10 degrees centigrade. Temperature of water is 10 degrees centigrade. Then at that condition, both the thermometers show the temperature as 10 degrees centigrade and 10 degrees centigrade. Clear? But if we keep here the freezing mixture, then because of this freezing mixture, the density of water, obviously this water cooled first. Because of the freezing mixture, the water in this bowl freeze first and cool. Okay, and because of freezing mixture, the density of volume will increase. Because here contraction of liquid. Okay, because of the contraction of this water, the volume decrease and density will increase. So because of increase in density, higher density, the water from this flat bowl will go in this cylinder, in this below cylinder. Clear? Why? Because the higher density of water, the water will go here. So the water will cool down, the water in this container will cool down, and the temperature of this water decreases rapidly up to 4 degrees centigrade. Up to 4 degrees centigrade. That means at first, up to 4 degrees centigrade, the temperature of T1 will decrease rapidly. But after the 4 degrees centigrade, that means the temperature of 3 degree, 2 degree and 1 degree centigrade of water, the density of that water will decrease, and so that the volume will increase, and that's why that water will go in the above container, in this container. Okay, and so the temperature will decrease rapidly up to 0 degrees centigrade. That means at first up to 4 degrees centigrade, the temperature of T1, temperature T1 of this thermometer will decrease rapidly first up to 4 degrees centigrade. But this water reaches 0 degrees centigrade first. Clear? Because the density of the water having a temperature 3 degree, 2 degree and 1 degree centigrade. So density will decrease, and density will decrease, that means if density will decrease, then the water will go, the volume of water will increase, and because of volume of water will increase, that water goes in the upside container, and that's why because of the cool water, comparatively this water, the temperature goes first at 0 degrees centigrade of the thermometer 2. So this is a working of this Hope's apparatus. So we will go through our textbook. Again I repeat the working of the Okay, for better understanding, I read the last paragraph. Initially, the temperature of water in the middle cylinder lowers due to freezing mixture. This is the middle cylinder due to the freezing mixture. Okay, lower due to the freezing mixture in the outer bowl. Since the temperature of water there decreases, its volume increases. I told you already the volume is inversely proportional to density. That means if volume increase, density will decrease. If volume decrease, density will increase. Okay. If higher density water will go downward and the lower density water will go upward. Clear? Now, the water with higher density moves downward. Water with higher density moves with downward. Why? Because of the freezing mixture, the density will increase. Because of the freezing mixture, the density will increase, and density will increase. That's why the water goes downward. Then, therefore, the lower temperature. Lower temperature means this. The lower temperature, the lower thermometer T1 show the rapid fall in temperature. Show the rapid fall in temperature. That means decreases the temperature, and till this continue till the temperature of water becomes equal to the 4 degree centigrade. I already explained this. When a temperature of water start decreasing below 4 degree temperature, that means 3, 2 and 1 degree centigrade, its volume increases. Understand? If volume increases, that means density decreases, and if density decreases, it therefore moves in the upward part, in the upward container. So the temperature of water in the upper part T2 therefore decreases rapidly to the 0 degree centigrade. Clear? So this is the working of this Hope's apparatus. And in your textbook there is a graph. Show the time temperature graph here, and here at a 4 degree centigrade, this is a horizontal line, because at 4 degree centigrade the temperature is constant, and here T2 reaches this T1 temperature reaches first at the 0 degree centigrade, and here in x-axis your time 5, 10, 15, 45. Okay, time is in minutes, and here this is the temperature in degree centigrade. So temperature to T2 before T1 temperature decreases up to 4 degree centigrade, but after 4 degree centigrade this starts slowly. Okay, this decreases slowly, and so before T2 reaches up to 0 degree centigrade, and after T1 reaches up to 0 degree centigrade. Clear? That means T2 decreases fast up to 0 degree centigrade than T1. But at start, T1, the temperature of T1 decreases than T2. Okay? But up to 4 degree centigrade. And after 4 degree centigrade, T2 reaches up to the 0 degree centigrade than T1. Clear? So I hope you understood this lecture, working and structure of the Hope's apparatus. If you have any doubt, you can message. So rest we will see, rest topic we will see in the next lecture. So till the time, goodbye. Thank you very much.